Okay, so, oops, I think I'm on the wrong page. I am on the wrong page. Flip book. All right, we got this yesterday. I needed you to add these notes. Do we have any questions on what an interior angle, exterior angle is, and a remote interior angle? That's vocab that you're going to apply. We okay with the definitions? Okay, so this was our parts. Most of you have that. That was given to you. Okay, I asked you to try to find the missing angles here using our triangle sum theorem, meaning if you add up the three angles inside the triangle, they equal 180. So if I try to add the other two, subtract it from 180, I think this one, what was the first one? This one was 49, and this one was 30. Yeah, 39. Okay. All right, so unfortunately, this is not how I'm going to check your understanding of the triangle sum theorem. I need you to start 3 and 4. Okay, 3 and 4 is how we will assess you using the triangle sum theorem. So number 3 was done for you. Okay, if you are giving expressions with variables, you're going to have to write an equation to solve for x using that the sum of the angles equal 180. So your equation should equal 180. So 3 was done for you. What I wanted you to do was solve number 4. Okay, I started the equation. We needed to simplify the equation. So hopefully we got 44x plus 4 equals 180. And then we solve for x. X was 4, I believe. All right. Okay, now I'm not going to ask for the x on your assessment. I'm going to ask for the angles. So we are going to ask you to put it back in here. Angle K. Basically, I plug it in 26 times 4, 104. Then we're going to do angle J, which is our 12 times 4 plus 2. So we should have, this one's 50. And then angle L, which was, what was that one? Oh, 6x. 6 times 26. All right, so questions on a problem like that? Okay, if you did, most of y'all got the first one right on the entrance ticket, so I'm not worried about this one. All right, so exterior angle theorem gave you the definition. I needed you to understand, and here's how you can show, because we're checking for your understanding on assessments. Know that right here, angle 4, if you label your exterior angle, I know that you're using that relationship to problem solve. So angle 4 is your exterior angle, which are our remote interior. 2 and 1. So our remote interior angles, and I'm going to abbreviate, are 2 and 1. Okay? So what they're trying to show you, the exterior angle theorem states, measure of angle 1 and angle 2. This is our sum of our remote. Okay. There we go. The sum of the remote interior angles will equal the value of the exterior angle, the measure of the exterior angle. So, number 1 was done for you. Okay, we did want you, they gave you angle ACB using the triangle sum, which was 48. So if you have a triangle sum, all the 3 angles, and you're trying to find the exterior angle, you can do it 2 ways. If I'm using my exterior angle theorem, then my angle out here basically equals 58 plus 74. Or you can use your linear pair. Since we have that's 48, we know this is a linear pair, I can just do 180 minus 48. Does not matter which method, just make sure you show that method to justify your answer. So we should have, what was this, 132. All right, so on number 2, we have the missing angle FHG was 26. They wanted you to find our exterior angle here. So 2 ways. You can add your remote interior, which will give us 154, or you can subtract it from 180. Depends on exterior angle theorem, applying it. Now, let's go ahead and start 4 and 3 on the next tab. Okay, oh, I went the wrong way, sorry. So we're we're going to, star these two. These are more like the assessment type questions. Okay. So I wanted you, they pretty much gave you their setup and their work and answers to number 3. I just added showing which one was the X tier and which is the remote in tier. I wanted you to use what they did on 3, watch their work, their process to solve number 4. All right, so we need an equation to solve for X. Who has an equation to solve for X? 9x plus 7x plus 4 equals 100. Okay. Or we can simplify that equation to 16x equals 96. Okay. So there's our equation. What's the value of x now? Value of x is 6. Now they are, and this is exactly what I'm going to ask you, is to find each angle measure. So angle K, we're going to have to plug it back in. We should have 46. And then, angle J, sorry. Angle K, 54. And guys, if you recognize the relationship, I want you to work smart, not overwork. Okay, so the exterior angle forms a linear pair with the adjacent angle inside. So the interior angle. What's the answer of the remaining angle? 80. Just subtract it from. We don't even have to add them up. Some of us were adding these up now. If you see a linear pair, just subtract it from 180. Do we have any questions on this? All right, so our extra examples. Let's do this. Okay, we will ask you to problem solve using triangles. Problem solve using triangles. If you did not get this copy, make sure it's in your spiral. We're going to check to see if you can get the missing angle. We're going to guide you through this together. All right, so angle 1. What type of angle is the measure of angle 1? What type of angle? It is an exterior angle. It's the exterior angle of this triangle right here. Okay, so how do I find the measure of angle 1? Yeah, add the 80 plus the 60, the remote interior. So we get 140. All right, so I'm going to go ahead and label it. I know they're asking for each angle measurement. Go ahead and label it on the diagram. It'll help you problem solve and find the remaining. So from angle 1, I can get angle 2 by doing what? Look at angle 1 and 2. What are they? Yeah, they're a linear pair. We have a linear pair right here because they're on this line. So angle 2 automatically is 40. We're done. Okay? So we're going to go ahead and put that into our diagram, our figure. I'm going to go label angle 240. All right. Let's move to angle 3. How are we going to get to this angle 3? Yeah, 105 is an exterior angle. Or we can go to angle 4. Couldn't I go to angle 4 as well? Okay, because angle 4 and 105 is a linear pair. So angle 4 we get 75. Angle 3, I would get 105 minus the 40, so that's 65. Okay, and then now that I have 75 for angle 4, how do we get angle 5? Yeah, it's an exterior angle, so we're going to do 40 plus 75. 115. Are we okay on that? All right. I used the exterior angle. Yeah. Angle. This is the exterior angle equals the sum of the remote. So basically, 105 equals 40 plus angle 3. In the triangle, I use this triangle. If I'm looking at this triangle here, 105 is the exterior angle. What 2 and 3? So 2 is the 40, so I just subtracted the 40 to get to angle 3. All right. Oops, still going the wrong way. All right. Problem solving. Problem solving. On this first diagram, let's see. Give me some letters that we can automatically just get an answer to. Don, you have one? C. Yes. Very good. Linear pair. C is going to give me 125. C and 55 are a linear pair. There's another one. Automatically get the answer to. Which one? B and E. E we should know it's automatically 90. B and 32 are complementary angles because we see that box right there. So we have 58. Okay. Now let's find our remaining angles. If I focus on a triangle at a time, okay, I can now find angle D or the D value. So what do we need to do to get this? Yeah, add the 125 and the 32, okay? That gives me 157. Then minus it or subtract from 180. So what do we have here? 23. We're going to do the same thing for angle A. Add our two angles, subtract from 180. What? Yep, 32. All right. Now, let's talk about finding two variables. Okay? On this example here, we're going to have to write an equation to find the variable. But we don't want to write an equation with two different variables in it, unless we're looking at a system. So, the parts that we have, just make sure you know. This right here, yes, it is an exterior angle. The 2y minus 1 and the y, remote interior. But right here, on this line that is extended, what do we have? Linear pair. So that's where you want to start. You first want to use your linear pair. So, since we have a linear pair, and a linear pair equals 80, x minus 28 plus the x equals 180. So we need to find x, because if I can get x, then I can use my exterior angle. So basically we have 2x minus equals 180. X equals dot dot dot. What is x going to give us? Yeah, 104. All right, so x is 104. All right, that is my exterior angle. Let me erase this. It's right here. I now know my exterior angle is 104. What can I do to get to y? Because we need to find the value of y now. Yeah, 2y minus 1 plus the y equals 104. Now use your exterior angle there. Are we okay there? Okay. So I think y is what, 30? 35, yeah. All right, now last one, example 3. Okay, this is really where we're going to start kind of embodying everything, kind of spiral everything into one problem. Not everything, but multiple skills. One of the things that's important is knowing that EC bisects angle BED. So I'm going to mark that in the diagram to show that it's bisecting. I'm going to add the arcs. Okay. And because they told me the measure of angle BEC is 23, I'm going to label it in there. Well, now I know angle C ED is also 23. So I'm going to label it in the interior to show that angle measure. All right, and then I'm now going to go, and I'm just going to show you ways they can label things differently and it still identify an angle. The measure of angle EBC is 4x minus 19. So here's that angle right here, right? EBC. Now, they might not write it in the interior, but they'll draw an arrow pointing to that angle. So that's my 4x minus 19. Okay, so if you see something outside the triangle and it's in reference to an angle, they can put it outside, even though it's talking about the interior. I said, just labeling wise, instead of putting, most of the time if I'm talking about an angle, it's the measure of the interior, but they might put the expression outside and point to it. Yeah, it's the same thing. Yeah, there's not enough space. Yeah, a lot of times they put it on the outside. Okay. All right. Then our other angle we have was BDA. Okay. So that was over here. 1, 2, 3. I'm just gonna point an arrow to that angle, and that is our 3x plus 13. Okay. Like if you put the expression on the outside, it doesn't matter where you put it. You just gotta show that it's pointing to the angle that it refers to. Yeah. All right. So how are we gonna work this out? What do we know? John, what did you got? You can find AEB. Yes, we can find that. What is the measure of AEB? Yeah, 180. I can get this angle over here because it's a linear pair. So 180 minus 46. Yeah, 134 right here. Okay, so 134 he's using this line, yeah, and the linear pair right there. All those three angles together, 180. Okay. All right, so yeah. Now, but we need to get to the x. How am I going to get to this x? Okay, 4x minus 19 does not equal 23. Let me help you out. Close. Do y'all see that triangle there? Okay, now we have the all three angles for that triangle. I could use the exterior angle too. Yes. Yeah. So you can do the triangle sum. So I can either use exterior angle theorem, which means I'm using the 134 equals 4x minus 19 plus 3x plus 13. That's using the exterior angle theorem. Or I could do the triangle sum, which means the triangle sum equals 180. So if I add up all the angles in my purple triangle, that would be 4x minus 19 plus 3x plus 13 plus 46 equals 180. Okay? So we can go either way. 46 is because I added the two 23s because it was bisected. Remember that angle got bisected? So, yeah. Okay? So, what is our value for x? Yeah. All right. Of 20. Yeah, so to get to BEA, we've already kind of have that because we did the exterior angle theorem. So we have this one already. Because BEA is, 134, I'm sorry. BEA we got with the exterior angle theorem. That was the first thing he gave us. B to E to A. That's the exterior angle. (180 minus 46). Yeah, angle BE. Yeah. Okay. All right, I need to show you something real quick, and then you have to give me your exit. Sorry. What? This? This is the exterior angle of the purple. 23 and 23 is 46 right here. I just used my linear pair. 180 minus 46. All right, guys. I need you to look at this. Okay, y'all see what we have up here? Okay, I need you to look at this. All right, what you have is a sphere. We've been doing Euclidean geometry. Euclidean geometry is two-dimensional, flat, on a coordinate plane, okay? Spherical geometry is when we're doing geometry concepts on a sphere. So the gray triangle is what we just did using triangle sum theorem. That's Euclid. That means that sum of the angles equal 180, always. So I just want you to notice something. Look at the black triangle. The black triangle is the triangle that's on the sphere. Okay, a sphere is curved. So look what happens. See this angle here? If I was to add up, do you physically see how this red angle is bigger than the angle on the gray triangle? So think about that. If I know the gray one has a sum of 180, what would happen if I added up my angles on my sphere? It's going to always be more than 180, okay? So the breakdown is Euclidean equals 180, spherical geometry, I'm just going to abbreviate, can be greater than 180. So if it equals 180, then what type of geometry are we dealing with? If it equals 180, it's Euclidean. If it's greater than 180, it's spherical. Okay, you have one question like that on the back of your entrance. Okay, you have questions on your exit. Your exit's on the back. Remember, if it equals 180, it's Euclidean. If it's greater than 180, it's spherical. So make sure you finish your problems on the back of your entrance ticket and put it in the tray or give it to me on your way out. You picked up your outline for your test, that packet. Make sure you pick that up. That is on Edmodo. There will be a key and a video explanation to the review problems. Tomorrow? Yeah. Yes.